He's considered to be the oldest human mummy found intact, and scientists believe he died more than 5,000 years ago. Because of new DNA technology, they're reimagining what he actually looked like.
For over 3 decades, Ötzi the Iceman has kept his secrets locked in ice, until now. When hikers stumbled upon his frozen body in 1991, the discovery stunned the world. But nothing could prepare scientists for what they'd uncover once his DNA was decoded. Could this 5,300-year-old man rewrite the story of European ancestry?
He was found in a glacier, frozen in time for 5,000 years.
Why did his appearance shatter everything we thought we knew? And how did contamination mislead researchers for more than a decade? In this video, we'll unravel the real story of Ötzi, a journey of science, mystery, and shocking truth.
He's the oldest human specimen we have, so well preserved, with all the scientific disciplines that are intrigued by him, that want answers. He may well be the most studied human being.
A discovery, frozen in time. It was September 19th, 1991, when 2 hikers, Erica and Helmut Simon, set out on what they thought would be just another alpine adventure. The couple, seasoned in navigating the rugged Ötztal Alps on the border between Austria and Italy, found themselves in a remote mountain pass at over 10,000 feet. The late summer sun had worked its magic on the glacier, loosening its icy grip and exposing pockets of ancient secrets. What they were about to stumble upon would shake the scientific world to its core. Half embedded in melting ice was the unmistakable form of a human body. At first, the Simons assumed they had found the remains of a recently lost climber. But as they approached, the details didn't match that theory. The man wasn't dressed in modern gear. Instead, his feet were wrapped in leather shoes stuffed with grass for insulation, and his clothes were made of animal hide and woven grass, primitive yet ingenious. Near him lay a copper axe, its blade green with patina, and a quiver of arrows alongside a flint knife. These were no relics from the last few decades. These belonged to another world entirely. Local authorities were alerted, and within hours, a helicopter carried experts to the site. Carefully, they began the slow process of freeing the body from the ice. When they finally managed to transport him to a laboratory, it became clear this was no ordinary find. The man was not skeletal. His skin was leathery but intact, his hair still clinging to his scalp, and even his last meal remained inside his stomach. This was a natural mummy, preserved by ice for thousands of years. Carbon dating yielded a startling result. The man had died near 3300 BCE, and thus belonged to the Copper Age. This made him the oldest known natural mummy in Europe, and a direct, tangible connection with a time long before written history, when early farming cultures were just beginning to settle, and metal tools were rare treasures. With every new examination, the stranger his story became. He had 61 tattoos upon his body, which were not merely decorative but offered healing along acupuncture-like lines that suggested treatment for his ailments of joints and arthritis. His clothing was functional and seemingly well-made. Goatskin leggings, a grass cloak, and a bearskin cap. Not only did he carry tools, but truly cutting-edge technology, most notably a copper axe. Such a luxury afforded him status in the Copper Age, designating him as a person of import or wealth. But the most disturbing details arose from forensic examination. His left hand bore a deep defensive wound. Bruises on his ribs suggested a struggle. Most shocking of all was an arrowhead lodged in his left shoulder, having severed a major artery. He would have bled to death within minutes. Blood from 4 other individuals was found on his gear, evidence of conflict shortly before his death. This was no peaceful passing in the mountains. This was a homicide scene frozen in time for over 5 millennia. Ötzi's discovery, as he was soon after named after the Ötztal Alps, posed an archaeological doorkeeper, a time capsule of a man's final moments, preserved in ugly detail. While scientific researchers were discussing his tools, clothing, and other wounds, they were perhaps still unaware that the most explosive revelations were somewhere deep inside his anatomy. Yet, while his death was dramatic, what lay hidden in his bones would be far more explosive, a secret locked in his DNA, the first DNA puzzle. For 2 decades after Ötzi's discovery, researchers extracted every clue they could from his body. They studied the contents of his stomach, the pollen in his gut, the wear patterns on his tools, but there was one realm they were just beginning to explore: his DNA. Ancient genetic sequencing was still in its infancy, and Ötzi, preserved in near-perfect condition, was the perfect candidate for one of the first full genome reconstructions in history. In 2012, a team of scientists announced what they called a groundbreaking achievement. They had decoded the Iceman's genetic blueprint. The results painted a vivid, if unexpected, portrait. According to the data, Ötzi had pale skin, brown eyes, and a genetic predisposition for cardiovascular disease. These findings alone were remarkable, but the real shock came from his ancestry profile. Buried within his genome was evidence of what geneticists call steppe ancestry, a signature linked to the nomadic herding cultures of the Eurasian steppe, stretching from Eastern Europe to Central Asia. This was a surprise because conventional timelines placed the arrival of steppe peoples in Central Europe about 1,000 years after Ötzi's time. If the results were correct, it meant these migrations had begun far earlier than anyone thought, rewriting the map of prehistoric population movements. The announcement sparked excitement across the scientific world. Here was tangible proof, or so it seemed, that our understanding of ancient European history had been wrong. Textbooks, documentaries, and even museum displays began to incorporate this new narrative. Ötzi wasn't just a preserved Copper Age hunter, he was a genetic bridge between early European farmers and later steppe herders. However, within a very brief period after the celebration started, small voices of caution chimed in. Some geneticists raised an eyebrow at the very own results. Ancient DNA research back in 2012 was in its pioneering yet exciting state, but it remained rather shaky. Sequencing methods were less accurate, and reference databases were limited, but above all, contamination loomed largest. Not even the merest touch of modern human DNA into a sample, and it could be because the researcher breathed, a stray skin cell fell off, or even through airborne particles, would affect the resultant data. Besides, numerous persons have handled the remains of Ötzi, increasing the odds of external genetic material mingling with his own. Yet the discovery of steppe ancestry for more than a decade remained immortal and inflating science popularization. It has simply been too forceful, too dramatic, to be thrown aside without anything more definitive to put in its place. The ghostly image of Ötzi became part of the tale which binds his fate, a symbol of the dark and tangled roots of Europe. But in science, no one theory is saint. In those 10 years that followed, sequencing technology advanced with astonishing speed. The new methodologies had enabled researchers to obtain clearer, more complete genomes, even from the most degraded remnants of ancient history. More so, tight protocols and multitudes of expanded reference datasets not only will, but have also allowed scientists to distinguish and filter contamination with a precision that was unthinkable in 2012. By 2023, the opportunity had arrived. A team of geneticists decided to go back to the source, to examine Ötzi's DNA again, using the most advanced techniques available. What they found would not simply tweak the story, it would obliterate the earlier conclusions, forcing scientists to confront the reality that the world had been telling the wrong story about the Iceman for over a decade. And then, a decade later, technology advanced enough to revisit Ötzi's DNA, and the truth flipped the entire narrative, a genome reborn. By 2023, the field of ancient DNA analysis had transformed beyond recognition. What had once been a delicate, error-prone process had evolved into a highly precise science. The mistakes of the early 2010s, contamination, incomplete sequences, and limited reference points, could now be avoided with meticulous protocols and massive global genetic databases. For Ötzi, this meant one thing. It was time to reopen the case. A new research team, including experts from the Max Planck Institute for Evolutionary Anthropology and URAC Research in Bolzano, decided to start from scratch. They didn't just want to recheck the old data. They wanted to rebuild Ötzi's genome from the ground up. This time, they chose a different source for DNA: dense bone from his hip. Unlike skin or muscle tissue, hip bone marrow offers better protection from contamination, locking away genetic material in a vault-like structure for thousands of years. The sequencing process was painstaking. Ancient DNA isn't like modern DNA. It's fragmented, chemically altered, and mixed with environmental debris. Researchers had to extract these microscopic shards, stitch them together digitally, and cross-check them against massive datasets of prehistoric and modern genomes. Every step was done under strict, sterile conditions, ensuring that no modern DNA could slip in and distort the results. When the final sequence emerged, the shock was immediate. The hallmark step ancestry that had dominated the 2012 findings? Gone. Completely absent. The genetic signature that had supposedly pushed back the timeline of Eurasian migrations by centuries had never been there at all. It was contamination, modern DNA that had crept into the earlier analysis and masqueraded as ancient heritage. The idea that Ötzi was a bridge between two worlds collapsed in an instant. In its place stood a new and even more intriguing profile. Ötzi's genome was overwhelmingly 92% derived from early Anatolian farmers, the Neolithic pioneers who had migrated from the region of modern-day Turkey into Europe about 8,000 years ago. The remaining 8% came from older European hunter-gatherer populations. This wasn't a mix shaped by constant migration and genetic exchange. It was the fingerprint of a lineage that had remained remarkably untouched for millennia. Ötzi, a man whose genetic characteristics differed from those of his alpine neighbors, became, in other words, an oasis, or even an island. His community quite likely lived in isolation from the rest of the world in the Alps, being shielded from sweeping population movements that had shaped almost all Europe during the Neolithic and Bronze Ages. And then came the most surprising twist of all. Scientists studied Ötzi's genome and found that his closest living relatives were not in the Alps, or anywhere near them. Instead, they were in Sardinia, hundreds of miles away across the Mediterranean Sea. The Sardinian population had maintained high levels of Anatolian farmer ancestry, probably protected from gene flow that diluted those lineages elsewhere by the isolation of the island. This new finding did not just radically change Ötzi's biography. It also questioned how strongly regional genetic affinities are tied to geography. For more than 5,000 years, his corpse had lain in the high Alps. Yet the tales of his DNA told of a people whose genetic echoes now reside far from that frozen grave. If his ancestry defied expectations, his appearance would dismantle them completely. The real face of the Iceman. For decades, the public had grown used to a certain image of Ötzi. Museum reconstructions, documentaries, and history books portrayed him as a pale-skinned, rugged mountain man with thick brown hair and weathered features, an image that felt comfortably familiar to modern Europeans. It was based on the best information available at the time, but it was also shaped by unconscious cultural assumptions about what prehistoric Europeans should look like. The 2023 genetic resequencing didn't just rewrite his ancestry, it demolished his physical image. The new genome analysis revealed a truth that left even veteran researchers doing a double take. Ötzi had dark skin, significantly darker than most people living in southern Europe today, and even darker than many modern Sicilians. This wasn't a suntan or the result of centuries in the ice. It was written into his genes. a product of his ancestral origins and the fact that skin lightening adaptations in Europe were still incomplete in his era. His eyes, long thought to be light blue or grey in popular imagination, were in fact a rich brown. This matched earlier but often overlooked evidence from his first genome, which had hinted at brown eyes but had been overshadowed by the step ancestry controversy. The new analysis left no room for doubt. Ötzi's gaze was far from the icy blue so often depicted in artistic reconstructions. Perhaps the most surprising detail was the state of his hair, or rather the lack of it. While early museum models showed a mane of unkempt hair flowing from beneath a bearskin cap, the 2023 genome revealed genetic markers for male pattern baldness. These markers, found on his X chromosome, meant he was already losing hair by the time he died at around 45 years old. The near-bald appearance of his mummified head wasn't solely due to the harsh conditions of preservation. It was likely how he actually looked in life. These revelations created a jarring disconnect between the icon the world had been shown and the man he truly was. For over a decade, the pale-skinned, hairy Ötzi had been immortalized in museum displays, media specials, and even textbooks. These depictions weren't intentionally misleading. They were built on incomplete data and the visual biases of the time, but they had nonetheless reinforced an inaccurate mental image of Europe's deep past. This changed image of Ötzi, for most people, was unsettling. After seeing the oldest natural mummy in Europe with dark skin, brown eyes, and a balding head, reckoning brought about unsettling changes. The most important of these was that pale-skinned populations of contemporary times around the world probably did not represent an entirely uniform resemblance of ancient Europeans. The case is evident with migration, isolation, and adaptation shaping diversity across time. To researchers, the updated image has now also served as an instruction in humility. The past history, generated by new tools and new data, continually and radically revises earlier pictures. Each generation of scholars generates reconstructions from the best evidence available at its time, but the narrative is always subject to amendment as such tools, new data, and new perspectives emerge. The true face of Ötzi was not just a discovery concerning one individual. Rather, it was a warning that our mental portraits of the past are far more fragile than we think. And beneath that weathered skin, his DNA told another unsettling story, one of disease, fragility, and survival. A body of disease. Ötzi's genome didn't just tell the story of where he came from, it laid bare the vulnerabilities written into his very being. The 2023 analysis revealed an unsettling genetic profile, one that carried the seeds of many conditions still familiar and feared today. He had inherited predispositions to heart disease, type 2 diabetes, and arthritis. His DNA also showed he was lactose intolerant, incapable of digesting milk in adulthood, a trait common in his time, long before dairy became a dietary staple in Europe. This wasn't simply a list of abstract risks. Physical evidence confirmed that many of these threats had already taken root during his lifetime. Examination of his arteries revealed significant calcification, an early sign of cardiovascular disease that could have led to a heart attack had he lived longer. His joints bore the hallmarks of chronic arthritis, and his tattoos, placed along acupuncture-like points, may have been a desperate attempt to ease the constant pain. Beyond the genetic predispositions, his body was a battlefield of ailments. Fragments of bacteria in his tissues showed that he carried Lyme disease, making him the earliest known human ever identified with this tick-borne illness. Inside his gut, scientists found parasites that would have sapped his strength and caused digestive misery. His gallbladder held stones, painful enough on their own, and his fingernails carried signs of severe physical stress in the weeks before his death. This wasn't a man in peak health felled suddenly by violence. It was a man whose body was already worn down by years of struggle. Living in the high Alps was no gentle existence. The climate was harsh, the terrain unforgiving, and food sources unpredictable. To survive meant enduring cold, hunger, and relentless physical exertion. Even so, what truly magnified these challenges was the genetic isolation of his community. As the genome data made clear, Ötzi's people had lived apart from the great population movements that reshaped most of Europe. This isolation preserved their ancient Anatolian farmer ancestry almost intact, but it also came at a cost. In closed populations, harmful mutations can build up over generations. With fewer opportunities for genetic diversity to dilute these weaknesses, vulnerabilities become concentrated. In Ötzi's genome wore the shadow of both the first farmers of Europe and a baggage of inherited susceptibilities. Genetically unique as his community may have been, they must have also been more fragile in ways that they could not understand. What most strikes one is how modern really his health problems really feel. We often think of heart attacks, diabetes, or chronic inflammatory conditions as diseases that mark our modern times, the price of being sometimes sedentary and consuming industrial diets. By this, we could prove through Ötzi's body that, indeed, these conditions had been creeping among our species long before modern man. For thousands of years, our biology has been propping against our environment, which in many ways still dictates our lives today. His life came to an end due to all these strands. His lineage was isolated. The ravages of disease, the harshness of his habitat, and the sudden violence that brought his life to a close. And through his DNA, we might not only see the narration of an individual, but also the reflection of ourselves, our sturdiness, our frailty, as well as our sheer connection with the struggles of those who preceded us in time. In the end, Ötzi's DNA didn't just reveal his origins, it exposed the complexity, diversity, and vulnerability of our shared human past. Ötzi's story reminds us that history is never final, and science keeps rewriting it. Like, comment, and subscribe for more deep dives into history's most astonishing discoveries. And check out the next video on screen to explore another ancient mystery that will challenge everything you thought you knew.